yet he's just completely filled with geometric detail as well as fairly complex animation detail. In addition to his primary animation, he's got all of these moving gears and parts and things that are all driven by expressions and formers, rigs that are proprietary. And so sometimes when we want to send these animations out to other packages that can't represent those types of rigs, or send them out to other facilities to work on the same shots with us, we can't send that rig out. Even if we could, we wouldn't want to. And so what we're doing with Alambic, what Tommy's going to do is show you, he just showed you Bumblebee in Maya, and now the same Bumblebee is going to come up in the little tiny viewer that we ship as part of Alambic. The Alambic source code contains this little tiny OpenGL-based, intentionally minimal viewer that allows you to just look at what's inside an Alambic asset without having to go into any particular software application. And that's really valuable. It's the same thing as, it's analogous to using an image viewer to look at your images after you've rendered them, regardless of what renderer or compositing package they came from. So one of the things that, that we can see with this is just kind of how much detail we can manipulate around, and we're able to bring that up really quickly as opposed to having to launch Maya or launch some other heavy 3D studio 3D package. So that right off the bat is like one of the most important things for us, is that all the flexibility in the world is useless if it can't handle the assets that we have to deal with as part of regular production. What we'd like to show you now is an example of moving between very, very different styles of application. Maya, to start off with, is, we all know and love. It's a complex character animation toolkit. And we asked our friends to come up with animation, our friends at Juicebox Animation, to come up with a little animation scene for us with our little octopus logo. And I wanted to do a fluid sim with the NVIDIA GPU fluid stuff, and that had an example of a tank. So we told them that we wanted to have a little octopus moving around in a tank and have something happen that would cause water to fill it up. And they just went kind of nuts. Can you pull that up again? Oh, theirs is in Maya. They sort of went crazy and did this whole giant animation, and they kept giving us new versions, and each one was increasingly more complex than the last. And interestingly, even though we had the same version of Maya and we weren't using any plugins, the first couple of versions we got from them loaded into our Maya incorrectly. And it was just, we had to track down a script and find an expression and hook things up the right way. But that was actually a perfect example in practice of why you need this. If you're going to be working with other facilities and with people in different parts of the world and with other tools, if this comes in for one shot incorrectly and it took us a couple hours to fix that over the phone, imagine that on a production where you have 2,000 shots or 3,000 shots. And imagine that where the assets are not, here we can see everything in the outliner at once. Imagine if that problem came in on something the size of Bumblebee or something as complex as some of the even heavier assets. So right off the bat, we had kind of a good use case for why we need this exchange format. But we took this animation and exported it to Alambic. And Simon Green from NVIDIA, I don't know if he's here. I don't know what Simon looks like. But that's actually another really cool thing, is that the collaboration we did on this, none of the people working on the various parts of this demo met each other or spoke to each other. So we sent an Alambic API to NVIDIA. Simon's in the UK, and he added it into a GPU fluid solver demo that he was preparing for SIGGRAPH, and we literally got the code for this like 5 days ago. But what you're about to see is a real-time fluid simulation. Hit E. And this is simming in real time. What you're seeing, the geometry you're seeing loaded there with the wireframe, is the scene we exported from Maya. The scene you just saw, exported, loaded into this GPU fluid solver. The fluid solver, Simon did not know what he was loading. We just sent him the API. And the version of the code he sent us, he had never seen this. And he, as the little octopus moves around, he leaves a wake behind him. It's going at about 10 samples per frame, so it's about 1/10 the actual playback speed. This, and so you can see as he pulls the little lever and it flips the floor around, it's actually splashing the water around. We can increase the particle count with this. Tommy can add and subtract forces. It's unconditionally stable. I accidentally left it running on back another desktop the other night and came in the morning 9 hours later and it was still running. And we built an export into this as well. So not only are you being able to bring in a Maya scene that you compose yourself and do whatever, load it into this GPU fluid solver, but then we can also save stuff back into an Alambic asset to show up in, Steve's going to show you all this stuff rendering in Katana. And I feel like that's a perfect example of the kind of jumping between very different tools. And tools, especially GPU tools, that are very narrow in focus and only do one thing but do it really well. We're hoping that this will facilitate these kinds of workflows. And with that, I'd like to turn it over to Steve.
Okay, so we received an email attachment with this geometry and loaded it up into the Katana lighting environment. So one of the things that Katana is based on is the idea that you can defer the loading and processing of the scene on demand, both in the interactive application and in the render. So the fact that Alambic offers random access both on a per frame basis and at the hierarchy level basis is really appealing for use in Katana. So I have an Alambic in node loading this scene up, and I can expand down, and if I choose to expand my scene, now we have our octopus loaded. It's only loading what we have currently visible. So as I'm flipping through frames here, it isn't bothering to even load the rest of the scene's data. So if I jump to a different part of the hierarchy and expand portions of the bar, you can see all of this stuff is here. If I choose to close that up, that stuff is gone. So in my simple little lighting setup, I've got some materials, I've got some lights, some settings down here, and I'm just going to hit render. And this is a live example of Alambic data being loaded on demand within the Arnold renderer through Katana. And that's my demo.
Switches over the map. So I think that what you're seeing here is really the combining of all these different things together, and it looks so seamless because that's what the great thing about the file format does, is it makes it very seamless to be able to work with.